Question 425. Kevin wants to fence off a rectangular field that borders a building. If 36 meters of a fence is to be used, what is the maximum area of the rectangular field that can be created? No fencing is needed along with the building. Okay, let's draw a picture that explains this situation. So here we have a building. Okay, so Kevin wants to fence off a rectangular field, right? So we have a rectangular field like this. And let width of the rectangle be x and length be y. Okay, he's using 36 meters of a fence. So 2x plus y must be equal to 36, right? And the question is, what is maximum area of the rectangular field? So we have to write the equation that represents the area of the rectangle, right? So area of the rectangle is just x times y. Okay, this is the optimization problem, and the key to solving an optimization problem is to have an equation with one variable, right? Here we have two variables. So we're going to use this equation to make this expression in one variable, okay? Y is equal to 36 minus 2x, right? So substitute this expression for y here. Then we are going to have x times 36 minus 2x, right? Now our area is one variable equation, right? So area is in terms of x. Now we're going to differentiate this equation with respect to x. Okay, well, before we find the derivative, let's distribute this. Let's expand this. That's a 36x minus 2x squared, right? That's area. And we're going to differentiate this. A prime x is equal to 36 minus 4x, right? So set that is equal to 0. Find the critical point. Okay, 36 minus 4x is equal to 0 when x is equal to 9, right? That's our critical point. Now perform the first derivative test. Okay, here is 9. Here our a prime. Okay, when x is less than 9, let's substitute 8. So 8 here. Then that's a 36 minus 32. So positive here, right? If we substitute 10, that's 36 minus 40. That's minus, right? So area A is increasing, decreasing. So the maximum area of the rectangle occurs when x is equal to 9, right? So far so good? So what's the maximum area? Here our area was equal to 36x minus 2x squared. Before we substitute 9, we're going to factor this. So that's going to be 2x 18 minus x. Now substitute 9 for x. So that's going to be equal to 18 times 18 minus 9. That's 9, right? So that's going to be equal to, use your calculator, that's going to be equal to 162. So maximum area of this rectangle with 36 meters of a fence is going to be 162. Okay? Question 427. A rectangle is inscribed by the circle with a radius of 6 centimeters. What is the maximum area of the rectangle inscribed in this circle? Here I have a circle and a rectangle inscribed by the circle. The question is, what is maximum area of the rectangle, right? So I'm going to let the length of the rectangle be x, width be y, right? The radius of the circle is 6 centimeters. So from the center right here, the radius is 6, right? But if we draw diameter from here to all the way to here, then that's going to be 12. So our diameter here is 12. Okay, let's write the equation. Since we're looking for the maximum area of the rectangle, we're going to have to write the equation of the rectangle, which is xy, right? And we have to change this expression in terms of one variable, either x or y. Okay? Here we have a right triangle, so we can write the equation x squared plus y squared is equal to 12 squared. Pythagorean theorem, right? Then we know that y squared is equal to 144 minus x squared, right? Then what is y? Y must be positive, right? Since y is width of the rectangle, that has to be positive. So y is equal to positive square root 144 minus x squared. So far so good. Now substitute this square root into y right here. So our area is equal to x times the square root 144 minus x squared, right? So our area is in terms of x, one variable equation, right? Now differentiate this equation with respect to x. So a prime of x is equal to, we're going to have to apply the product rule since this is x times the square root of 144 minus x squared. So derivative of x, that's 1. Square root 144 minus x squared plus x times derivative of square root 144 minus x squared. That's going to be 1/2, right? 144 minus x squared to the power of negative 1/2 times chain rule. 144 minus x squared. Derivative of that is just a minus 2x, right? So that is equal to square root of 144 minus x squared plus, here that's gonna be, cancel this one out, x times the negative x squared in our numerator. In denominator, that's gonna be 144 minus x squared, square root, right? Okay, we're gonna have to simplify this expression right here. So actually square root of 144 minus x squared is, let me erase this, that's gonna be actually equal to, if we have the denominator 144 minus x squared with the square root, then numerator we have 144 minus x squared, right? So that is equal to denominator square root of 144 minus x squared. Numerator we have 144 minus x squared minus 2 x squared, right? Okay, so let's find the critical point. Set that is equal to 0. So critical, well, a prime is equal to 0 when numerator is equal to 0, right? So 144 minus x squared, 2x squared. 2x squared is equal to 0. So x squared is equal to 72. Then what is x? X is the square root of 72, right? Which is equal to 6 root 2. That's the only critical point. And the area of the rectangle is maximum when x is equal to 6 root 2. Okay, so what's maximum area? Maximum area is when x is equal to 6 root 2, right? So area A is equal to x times y. So when x is equal to 6 root 2, what is y then? Here, if we substitute 6 root 2 here, y is going to be 144 minus 72, right? So y squared is equal to 72, which means y is also equal to 6 root 2. So times 6 root 2 gives us 6 root 2 squared. That's going to be 72. So the maximum area of the rectangle that is inscribed in this circle is equal to 72. Okay? Question 431. Find the point x, y on the graph of y is equal to square root of x plus 2 that are closest to the origin. Here we have coordinate plane with x-axis and y-axis, and let's draw the graph of y is equal to square root of x plus 2. So that starts from -2 and it looks like that, right? It's radical function. Y is equal to square root of x plus 2. And we're looking for the point on this curve right here where it is closest to the origin, right? So here is the origin. It looks like a closest point is somewhere here, right? So I'm going to let this one is equal to x comma y, and the origin is always 0 comma 0, right? So let the distance from here to here be d. Okay, so we're going to start with the equation of the distance. So d is equal to square root of, using the distance formula, x2 minus x1 squared plus y2 minus y1 squared, right? So that is equal to square root of x squared plus y squared. So far so good. Now we have to rewrite this equation in terms of one variable, either x or y, right? We know that y is equal to square root of x plus 2, right? So y squared is equal to x plus 2, right? So substitute x plus 2 for y squared right here. So that is equal to square root of x squared plus x plus 2. Now we have a distance, equation of the distance in terms of x. Now we're going to differentiate d with respect to x, right? So we have a d prime x is equal to, remember square root is x squared plus x plus 2 to the power of 1/2, right? So the derivative of that, that's 1/2 times x squared plus x plus 2 to the power of -1/2 times the derivative of this expression right here, chain rule. So that's a 2x plus 1, right? So if we rewrite this, denominator will have a 2 times the square root of x squared plus x plus 2. Numerator we have a 2x plus 1. And we have to find the critical point, right? So let this be equal to 0. Okay? So all of this expression is equal to 0 when numerator is equal to 0, right? So d prime x is equal to 0 when 2x plus 1 is equal to 0, which means x must be equal to -1/2. So far so good. Okay, that's the only critical point, which means the distance is minimum. The distance right here is minimum when x is -1/2, right? But if you want to do the first derivative test, you can always do that, okay? Here's x, So negative 1 over 2 here. And let's look for the sign of the prime. When x is, let's say, negative 1, if we substitute negative 1 here, right, negative 1 for x, then the prime will be negative, right? So here we have a negative. If we substitute any number greater than negative 1 have a 0, let's say, then this is going to be positive. So distance is decreasing and increasing, right? So this distance is minimum when x is equal to negative 1 over 2. The question is to find the point, right? So this x value right here, that's negative 1 over 2. And when x is negative 1 over 2, when x is negative 1 over 2, what is y? Y is equal to square root of negative 1 over 2 plus 2, right? So that's going to be equal to square root of negative 1 half plus 2, that's 3 over 2. So if we rationalize this, that's going to be square root of 6 over 2, right? So the point has to be negative 1 over 2 comma square root of 6 over 2. That's our answer, right?